So this is touch answers. The previous chapter we generated the simulation waveform using model form. So we just discussed the previous videos how we can that RTL design flow and for simulation and synthesis. So everything we discussed in previous videos. Now once if you used using the model sim Xilinx like that, when you use the coding to simulate a synthesis. After that, you have to know what is the output of the circuit. So using these test benches, you can give directly to the input signal values manually. Then the number of input signals are very large. If we have to perform the simulation several times, the process can quite complex, time consuming, and it's too difficult. So the impossible to manual actually the thing is test bench is if you're going to give the values manual if it is simple program it is easy, it's not a big deal. But if it is the program is too big, so every value you can't give manually. So that's why we have it's too difficult and it quite complex. So that's why we go to the test bench. It is very useful for testing the design. So further the help test benches we can generate results in the form of CSV, which can be used other softwares also for their analysis, Python, Excel, MATLAB, etc. So since the test bench used in simulation process only, not for the synthesize, and VSL construction can be, dashboard, report, for loops, etc. can be used for writing test benches. So model sim project it created in this chapter for the simulation. Uh, so you know that the simulation part creating the project also we have to see that coming codes we see that the ultra model sim everything we have to do compile this kind of simulation codes half adder. So this is basic half adder coding. So library IEEE use IEEE standard logic 1164. So this is calling IEEE files and entity half adder is support a comma b. So this is input standard logic and sum and carry output standard logic. So this is basic input pushing through the gate. So here the input is half adder, basic half adder have two input and two output. So A and B is input and sum and carry is output. Then the header file entity end half adder, then body of the program architecture. So arc that's the name of the body. Then half adder its header file name is begin. So so we know that what is output sum and carry. So what is output sum you have a x or b and carry a and b and end this body that arc on the name. So end of the program. So this is basic half adder coding. So simple test bench for half adder. So they return everything entity half adder simple test bench and half adder. Okay, the architecture test bench of half adder. Okay, and signal a and b and someone carry our signal that input and output they put it as signal and begin and then so they have to entity work have order port map a to a b to b some carry a carry. So entity work so same values. So 0 0 you have to okay, there are two inputs, so only four possibilities available: 0 0 0 1 1 0 1 1. So only so 0 0 is started at 0 nanosecond, then 0 1 is a 20 nanosecond. So B, so the in between that time duration is 20 nanoseconds. So 10 is a 40 nanoseconds. So 11 16 nanoseconds. So this is the inputs. So if A 0 and 1 after 20 nanoseconds, 0 after 40 nanoseconds, 1 after 60 nanoseconds. So A, so see consider this is A. This total part is A. So A is 0. Okay. Uh, so 0 and 1 after 20 nanoseconds 0. Then after 40 nanoseconds it is 1. After 60 nanoseconds, okay, so after 60 nanosecond it is 1. After 40 nanoseconds it is 0. After 20 nanosecond it is 1. So like that they put this a value and b value also similarly. So a and after the what are the values they put it. So similarly then end the test bench. So this is basic test bench. So if there is a two input, so you can manually enter four possibility. So if it is three input, 0 to 7 to 8 possibility is available. If the input is more, so more possibility is available. So here the test bench we have to write like that. This is the basic simple test bench for half adder, and this is a simulation for half adder. So once if we run all, so automatically it will be run all the so every 20 nanosecond, 40 nanoseconds, 60 nanoseconds they will be change the output. So then you will be get the test bench result. Okay, thank you.